Hi everyone, I'm Rebecca Solcia and today I'm here to talk to you about a project I've been working on for the last month together with my group mates at Bocconi. So in this case we've been working on the Blockchain for Italo project, and this is a project we've made for the FinTech class. The main aim of this video is actually to walk you through the whole code, give you an understanding of what you can find in the Readme that we're seeing here, and then basically allow you to deploy a smart contract on chain, of course on a test chain, Kovan in this case, and also deploy a web service that is going to be used from that contract through oracles. Let's go back to the origin of the project. So the idea of this project is to allow Italo, which is one of the most important Italian train companies, to speed up its compensation process when a train delays. Of course, this process will be kind of automated, and we will make use of blockchain solutions, specifically a smart contract, to allow Italo for this speeding up of the compensation, and also to ease the compensation claims on the side of the person whose train is delayed. So as you can see here in the README, we describe the web service in which there's going to be functions like the search ticket and the check delay ticket that are respectively looking for the availability of a train ticket inside of the Italo website, and then the check delay will allow the user to buy a ticket, to check the delay of its train in case, of course, its train is delayed and he wants his compensation back. But these are gonna be just check functions, because the true stuff is going to happen inside of the smart contract. The smart contract, specifically the compensation smart contract, which is our dev environment, contains the request info function that is the function that will allow the user to ask for a ticket for the availability of the ticket specifically. This function will also store a claim inside of the smart contract for that specific ticket, and then the user, upon a specific payment of a fee that will be indicated after the request info is called, can of course buy a ticket. The ticket ownership will be stored inside of the contract, and then of course in case of delay the user can ask for a compensation. Why have I said dev and not prod? Because the production ready smart contract can be used, but not for tutorial purposes, because of course we would have to buy the ticket, but then we would have also to wait for the train to delay for real to then ask for the compensation. Of course, when I say buy a ticket also in production, I don't mean that you can actually buy a ticket from Italo and then go from Milan to Rome the next day. It just means that it's something that can be, it's just a proof of concept. So something that hopefully, if Italo sees this, could be used to speed up the compensation process for real. Okay, so here is the README, and let's start. You would have to clone the GitHub repo from here, make a git clone, of course, and then in PyCharm you will see something like this. So the blockchain for Italo code, I've already cloned it and installed the requirements through pip install our requirements, txt. And then what we are going to do is, of course, to make our web service run. So let's go to code. You will find the Chrome driver, which in this case might be working for my Chrome version, but might not be working for yours. So of course, look for a Chrome driver that suits your needs. This is just a placeholder for you to know that there must be a Chrome driver. Then we can, of course, run the web service. And another thing we can see here is that while this web service has been deployed with Fast API, I have specified the port of this web service to receive the call as 400. When we're gonna call the oracles, in any case, we cannot run in localhost. We're gonna need some public to private tunnel that allows all of the calls from external, let's say, external computers, external IPs to enter, let's say, my local host. To do this, I have used the ngrok exe. Ngrok is actually a tool that you have to install and that can allow you to make this public to private tunnel I've mentioned before. The command for ngrok to run this specific tunnel is ngrok http. So an HTTP external address should translate the calls, should, let's say, forward the calls to my local host, at which port? At port 400, which is the port in which my server is running. As you can see, we're gonna get an address here that will be useful for the contract to run, of course, and that we can store for now. So let's keep it running. Let's now switch to the workspaces. What happens here is that we have the Remix compiler, which is a compiler for Solidity language that can actually deploy your contract over a testnet. One thing we're going to do is to copy the GitHub files we're gonna need. So the contracts stored inside our GitHub to then deploy them. So as you can see here, we can import from GitHub. We can go to code. We're gonna need the compensation.sol file, but also the library utils, which is the contract that is going to allow us to use specific utils and tools inside of our contract, such as tools for transforming a uint to a string or bytes to string and vice versa. So we can safely do this. We can import this file, but then we can also import this file. As you can see, Remix is not exactly immediate, so we're gonna have to refresh and see. Okay, so in here you can see GitHub Repsolcha, which is my name, Blockchain for Italo, and then code. Here we have the compensation code and the library utils code. As you can see, the extensions .sol, of course, mean that they are written in Solidity. The library utils contract can be, let's say, ignored for now. And in this case, we have also the compensation, which is the contract we're gonna work with. Now, let's see. I will try to compile compensation.sol with Pragma Solidity 0.5. So we're gonna need a compiler of version 0.5.0. Of course, it doesn't find the library utils.sol because it's located in a different folder from the one I used to have. So we're gonna have to specify the path. Okay. As you can see here, it has now compiled, so it is ready to use. Actually, not that ready, because as I said, in here, we're gonna make some calls. So instead of the request info and instead of the check delay functions that are gonna look for our web service, which is now running local, but then, as I said, calls can be tunneled from public to private. So in this case, we're gonna copy this ngrok address and make sure that we have it stored, we have it changed inside of this contract. Let's recompile, and then we can deploy. Before deploying, make sure that your MetaMask account actually is set first on the Coventes network and has enough resources, meaning enough Ether and enough link, which is the token that the Chainlink oracles are going to use to make the calls. So it's as if it was a gas fee, but for Chainlink oracles. If you're looking for these type of resources, you can, of course, use the faucets provided by Chainlink. Make sure that you select Ethereum Coven, copy and paste your address here, as I already did, and then tick both boxes. Make sure, ensure the post that you're not a robot and send a request. Sometimes it might break. This is not the case, luckily. So we're gonna wait for confirmation, and then we're gonna see that tokens are transferred. Our balance is going to increase, as you can see here, and we're now ready to go. Let's deploy the contract. Make sure that you're deploying the right one. Let's go. Okay. Oh, sorry. Remember to put injected Web3 and then deploy. Of course, this is super important. Don't make my mistake. We're gonna wait for the contract to be created. This is our contract. The very first thing we have to do is to transfer links to our contract. So fund our contract with links. We're gonna be generous and give it 2 links because, as I said, Chainlink uses for each call 0.1 link of gas. Therefore, in this case, we're going to be able to make 20 calls. Okay. I guess that the links are ready, so we can now request info. Request info is, as I said, this function. Let's go to the function that basically takes these inputs, sends a Chainlink request to our web service, which is now running and listening on port 400 through this tunnel we made, and then will allow the user to make a claim for a ticket. So for example, if we want a ticket from Milano Centrale to Roma Termini with train number 9991, of course, you will not be specifying these informations inside of the production ready contract, but in this case, yes. The date time of departure as 1420, it will take like 4 hours. So it will arrive at 1820, and then it will cost about 89.99 euros and transact. Of course, MetaMask will ask for a confirmation of the transaction. And now we're gonna have to wait for the call to be made and the ticket to be stored inside of the contract. As you can see, this is confirmed and we're gonna wait on our web service, which is storing all of the calls, whether the call has been made for sure or not. And in this case, as you can see, we have called the fake ticket search method with arrival station Roma Termini, departure station Milano Centrale, with that certain price we specified, and so on. So the ngrok tunnel is working, the contract is working. And as you can see, the function we have called, so the request function outputs very important information. So your ticket has been successfully stored inside our database. To buy it, please insert the following request ID inside of the counter to Kekka function. After having retrieved the Kekka encoded counter, go inside of the public mapping request ID and query the price of your ticket by inputting it these two parameters, the Kekka encoded counter and the number 4. So let's put our ID inside of this function, counter to Kekka. Then we have to request the price of our ticket through this address I've copied and pasted here and the number 4. As you can see here, the number 4 returns 22. What is 22? Once you have retrieved the price, please make sure to insert that specific number, so that's 22, or whatever number will pop up in Finney as the message value when you buy the ticket. So we have this, let's say, Kekka encoded counter, which is nothing more than a ticket when you go and buy the bread or when you're waiting in line. So you say, hey, I have this number, I ordered this thing, in this case, our ticket from Milano Centrale to Rome, with train number, this train number from this time to that time at this certain price, and then we can now buy it. Okay, so let's buy the ticket by copying once again this code and pasting it here. And remember that we have to pay for the ticket in Finney. So let's pay 22 in Finney. Let's confirm the transaction. And now let's wait for our ticket to be bought. Okay. Fine. So we have bought the ticket, and as you can see, the message here after having bought a ticket says, you have successfully bought your ticket from Milan to Rome. The train 9991 is scheduled to arrive at this time, which is the Unix timestamp. Make sure to ask for a refund in case of delay. Thanks for choosing our service. So fast forward, we have this train for tomorrow at 2:30 p.m. We should be arriving at 18 in the afternoon, and our train tragically delayed. So let's suppose that it has delayed 65 minutes. We can check the delay. So the train number here is, sorry, the expected arrival is this one. The train number is this one. And then we can simulate the delay by saying it has made a 65 minutes delay and the threshold of maximum delay should have been 10 minutes. So we're gonna now enter the check delay function and see what happens. Once again, we're gonna make an API call to our web service. Let's wait for our call to arrive inside of the web service. Okay, the call has gone through. And as you can see here, the call has arrived. Delay 65, as we inserted, this is the expected arrival time we put inside the inputs, the threshold, and the train number. So if it has delayed, we should be able to see inside of the contract something interesting. So this is the contract. These are the interaction happening. And as you can see, this is the ether I sent to the contract when I paid for my ticket. But then what happens? I've asked for a refund of 65 minutes. This means that our contract actually will return, as you can see here, we return 60% of our initial price we paid. So it should return 60% of our 0.022 ether. And as you can see, the balance inside of the contract right now is 0.009 ether, which is about 40% of that 22%, the 0.022 that was initially stored inside of our contract. This means that we have successfully bought a ticket, provided the contract, gave the contract the price of the ticket, and then the contract has given us back 60% of that amount, and therefore kept 40% of 0.022 ether to give our compensation back in case of delay. So I hope that everything is fine, and if you have any doubt, please feel free to contact us. Thank you a lot.